Hi, I'm Don Cohen from Michigan Metrology. Michigan Metrology has been in business over 30 years now. And what we do is basically measure and analyze the surface roughness of all kinds of components, from automotive components to components in the aerospace field, or hydraulics, anything of that nature. I help people solve problems related to squeaks, leaks, friction, wear, appearance, adhesion, other things that relate to surface roughness. Another field that I do a fair amount of work in, though, is actually the medical field. Turns out there's quite a number of critical surfaces in the medical industry, and a lot of different applications in which we're looking at moving parts against each other in the human body. Hip implant, knee implant, ball and socket kind of joints and knee joints. They all come down, though, to something rolling or sliding against each other, and there's a lot of those kinds of things in the body, and then we're concerned about the friction there and possibly the wear as well. And so the surface finish is something that people look at in great detail. I work with a very specific instrument, the Bruker NP Flex. It's basically what's called a vertical scanning interferometer. The light comes down from the head on top and it hits the sample. But in the middle of this lens, there's a beam splitter and sends half of the light off to this side, which has a perfect mirror. And then those two beams of light recombine and get re-imaged. We get what's called interference. The microscope is going to scan vertically from the top down. It's going to grab every pixel in that image and look for the brightest signal, basically the brightest fringe moving by, and is able from there to localize the height of the surface to within nanometers. The component that's on the stage right now is actually part of an assembly that's used for spinal implants. And this is an articulated kind of joint where things are moving. And when things wear out or whatever, people have developed devices that replace our biological bearings with some mechanical implanted bearings. We're able to, with this NP Flex, swivel the head and kind of sneak in at odd angles. I'm able to work with the clients to develop fixturing to hold in that part. So together with my microscope capability of swiveling as well as their 3D design, we're able to make some nice fixtures. This is a pretty smooth surface, average roughness of maybe a couple nanometers. In the medical field, the smoother surfaces are usually sought after, from a bearing point of view for lower friction, as well as the fact that whenever blood comes in contact with a surface, if it's not quite the right kind of roughness, the blood has a propensity to start clotting. So there's a whole science behind what type of surface texture is optimum for blood to flow on. Things like heart valves and heart pumps, we're able to measure that, quantify it, as you see, in great detail down to the angstrom level. We've been involved in a lot of different medical applications. The optics area, the eye, lenses that are put in your eyes when you have cataract surgery. I get involved in a lot of different phases of the development, from the early days where people are just simply trying to make some kind of device. But once people get into a mode where they're starting to go through FDA qualification, then the number of parts increase, and we need to sometimes build up some fixturing, build up some automation, so we can measure maybe tens to hundreds of parts. With some automated computer-controlled staging, we can get the price down pretty reasonably and the throughput. As I mentioned, I'm here to help people solve problems related to friction and wear and surface finish. Primarily a measurement lab where I work with people and measure their parts. I'm located here in southeastern Michigan in the Detroit area. Bruker and I work together. I do demonstrations for them here. Feel free anytime to visit the website, to set up a meeting via Teams, and we can meet and discuss your applications. If you're in the Detroit area, feel free to set up a time to come by and visit, bring some parts. And again, just feel free to send a few samples in for no charge. I'll take a quick look and see what we can do.